to give you the revision of our end of term final exam 2023-24. This is statistics exam, and the study list is in front of you. The chapter number 5, probability distribution and discrete random variables. This thing we will discuss while solving the past paper questions. We have chapter number 6, permutations and combinations. And then the last chapter, chapter number 7, which is the binomial distribution. Guys, please note down the exam will be 90 minutes long, and the total marks for the exam will be 30. Spaces will be provided for working under every question or part. MF19 formulae, I will discuss with you after this, will be provided to you, and it will be enclosed in the exam. Scientific calculator, it is expected that you have to bring with you, and the recommended calculator is FX991EX. Okay, so if in the exam you want to draw any diagram, we are actually allowing you to use pen, but pencil is recommended to draw the diagrams or graphs with ruler. In MF19, the formulas which will be helpful for you in the final exam, these are these formulas: discrete random variables, the expected formula, and the variance formula. We already know about it, and inshallah, we will discuss it during the solution of the questions. And the next thing is the binomial probability distribution, which is also one of the application of discrete probability distributions. The formula for binomial probability distribution is this. He uses column vector, but I will write NCR P, and this is your 1 minus P is also called Q raised to power n minus R. Mu, the expected value or the mean of binomial distribution, is NP, and sigma square, which is called variance. Sigma square is the variance, and that is equals to NPQ. Both formulas are very important, but for this exam, we are not going to talk about geometric, no Poisson distribution, which is for further maths, continuous probability distribution for further maths, sampling and testing, it is for further maths. So it won't be useful for your exam. Now let's start with the first question. The first question is, a book club sends 6 paperback and 2 hardback books to Mrs. Hunt. 6 paperback books and 2 hardback books, total 8 books. Total books 8. Out of them, 6 paperback books, 6 paperback books, and 2 hardback books. It's better to write it here on the side. She chooses. When the word choose comes, the combination concept comes to my mind. Selection, chooses 4 of these books at random to take with her on holiday. Done. The random variable X represents the number of paperback books. Now, paperback books are 6, and she wants to take, some paperback books with her. In total, she is going to take 4 books with her. So there are many possibilities. So suppose if she picks all paperback books and she doesn't take any hardback book with her, maybe she takes 3 paperback books and 1 hard paper book. And you remember that sum of the books should be 4 because she is going to select total 4 books. Do we have any other option? She may have 2 paperback books and 2 hardback books. It is equals to 4. Can we have 1 plus 3? No, we don't have 3 hardback books. In total, we have 2 hardback books. So there are only three options are left to us. The first question, it says show when in exam it is written. It means that examiner will give you the answer, that you have to get the answer like this. What is we have to show? The probability that she chooses exactly two paperback books, exactly two paperback books, guys. So if she picks two paperback books, then two hardback books she's gonna pick. So we want to find the probability in this case. So how to get this probability, boys? Uh, your random variable is basically representing the number of paperback books. They may be 2, 3, and 4. In this case, examiner is asking you what is the probability of x is equal to 2 if she picks two paperback books. You remember when we write the probability, we have to write always in the denominator without restriction. Any without restriction means like how many total books she has. She has 8 books and she wants to pick 4 from them. So denominator is always without restriction. Restriction will be seen, which is related to x is equal to 2. We will write it only in the denominator. So in the denominator, what I'm going to write, guys, how many total paperback books she has? 6, and she wants to pick 2 from them. How many hardback books she has? 2, and she will definitely pick 2 from them because we are talking about this case. Clear? Now we will look into our calculators, and the calculator gives it to us 15, and this will be 70. And then we can further simplify it. It will give us 3/14. And this answer is matching with the answer given by the examiner. Got it, boys? Now let's go to the second part. In the second part, he says we need to draw up the distribution table for x. So the distribution table for x is, and you have x, which may assume 2, 3, and 4. And now I'm going to write the probabilities under them. So probability of 2, I have already found it, which is 3/14. However, I did not find the probability for 3. That's not difficult. In the denominator, as I said, you have to write the total possibilities, or without restriction, total 8 books, and she wants to pick 4. Same thing I repeated for the case when she's going to pick 4 paperback books, total 8, and she's going to pick 4. Now in the numerator, I'm going to write in the numerator, I am going to concentrate how many paperback books in total she has. Paperback books is 6, and she is going to pick now 3 paperback books. Remaining are 1, and in total 4 she wants to pick. And how many hardback books is 2? Let's come to the third case when 4 paperback books she wants to pick with her. Okay, so total paperback books 6, and she will pick 4 hardback books. This time she will not pick any hardback book with her. After solving this with the calculator, I'm going to get 8/14. This is the answer for the second case when x is equal to 3. And I will get the answer for this one by using calculator. It would be 3/14, guys. You need to check in the exam the sum of the 3 probabilities should be equal to 1, which will validate the discrete probability distribution. Yes, 3/14 plus 8/14 plus 3/14 is 14/14, which is equal to 1. Now let's go to the third part. Examiner has given you the expected value and asking you what is the variance. Now let me explain you what is the definition of expected value. If I give you a table, suppose this is X and this is X is equals to X, X1, X2, X3, and X4, P1, P2, P3, and P4. The expected value formula, which you also have seen in the MF19 formula sheet, that we need to make the product of the corresponding terms, yani X1 random variable multiply with its corresponding probability, plus X2 P2, plus X3 P3, plus X4 P4, or in other words, we can write it as sigma. Sigma means addition of the product of X and P. Got it? But this thing has been already provided by the examiner, so we need not to worry about it. This is already given. Expected value is how much? 3. Now he's asking you variance. The variance is equals to, you always have to take square of the random variable, then multiply with the corresponding probability, x2 squared, multiply with the corresponding probability, x3 squared, multiply with the corresponding probability, x4 squared, p4. Once you do this, then minus expected value square. And this formula you have seen over there in MF19, where they wrote sigma x squared p minus ex squared. So the product of square of the random variable with the corresponding probability. And sigma tells you that we need to add all these products. So my friends, you already have an idea about the formula for the variance. Now I will look at my x1. My x1 is 2. And my corresponding probability is 3/14. Did you see? I did not take the square. So square of the random variable multiplied with the corresponding probability plus square of the random variable multiplied with the corresponding probability plus 4 squared 3/14. After doing this, now I write minus expected value. Expected value is given to me 3. I put 3 squared. And the final answer will be 3/7, or I may write it in 3 significant figure, 0.429. That's the final answer for this question. So my friends, in this question, I have tried to explain you the concept of discrete probability distribution table, how it is constructed from the random variable, which is given according to the situation. Okay, in this situation, my random variable was depending upon the number of paperback books. So the paperback books total 6, but my random variable for paperback books was 2, 3, or 4, as she was selecting only 4 books in total. So 3 cases were possible for me, and the random variable was assuming 2, 3, and 4. And then I wrote the 3 corresponding probabilities. Then after that, examiner gave me the expected value. With the help of that, I found the variance. Sometimes in the exam, examiner asks you expected value and also ask you the variance. But variance cannot be calculated unless we have the expected value. So question number 2, guys. A pet shop has 9 rabbits for sale, 6 of which are white. So total, you can see total 9 rabbits we have, and 6 white and 3 are not white. A random sample of 2 rabbits is chosen without replacement. Do you understand? Without replacement. This point has to be noted. When I say that we are going to pick the rabbits without replacement, so this is related to classical probability. Don't try to use here combinations. Why we cannot use combinations? And you say, Mr. Romer, it is written chosen. My friends, he has written without replacement. Whenever we do without replacement, if you pick something in the first trial and you go for the second trial, definitely the number of items will be reduced because something has to be taken out and it is not included into the second trial situation. Am I right, boys? So be careful about these type of questions. Whenever in probability without replacement is written, try to deal it with the classical probability cases. Okay, anyways, two rabbits are taken. I can draw, the tree diagram. The tree diagram will be very helpful for you. White, not white, white, not white, white, not white. So basically, we have only four cases. What are those four cases? Let me write it. White, 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 not white and white, and not white, not white. So these are the four possible cases we have. Now, examiners says show that the probability that exactly one of the two rabbits is in the sample is white. So we need to go with this case and also with this case. So there are two possible cases we have. So we can do the probability like this. If the probability of white, I'm gonna check that, guys. What is the probability of white? Hurry up. Probability of white. The probability of white is 6/9, and this is, hurry up, this is 3/9. Didn't I tell you this is a without replacement question? So white will be how much now? 5/8, and this is 3/8. This is 2/8, and I'm gonna write it here, 6/8. Now I want to write the probabilities. 6/9, 6/9 times 3/8, and the second case is 3/9 times 6/8. Clear? And then you add these cases. The final answer will come to you 1/2, which is matching with the given situation. Now, a student is saying, no, Mr. Romer, this question is having only 2 marks. If it is having 2 marks, why we cannot do it with the combinations? We should try with the combinations. What's wrong with the combination situation? Okay, let's do it. First of all, you need to confirm all of the rabbits are different. Yes, all the rabbits, 9 rabbits are different. They are not similar at all. Okay, now all the 9 things are different. That's why I'm going to apply the formula for combinations. And I'm looking for, may I assume my x can be because I'm gonna pick 2 rabbits from them, and without replacement. The first question is, yani, I'm going to define the probability distribution. Suppose the number of white rabbits, okay, white rabbits. In the first part, he says exactly one of the 2 rabbits is white. Okay, so white is that case which will help me to describe, to define my random variable. So x represents the number of white rabbits which can come in 2 selections of rabbits. So no white may be coming, maybe 1 white comes and 2 white comes, right? And in this case, examiner was asking you, he's gonna pick 1 white rabbit. So total rabbits are how much? Total 9 rabbits I have, and I want to pick. I want to pick how much? I want to pick 2 rabbits out of them. Clear? And he says that white rabbits are how much? Did I write it? we were having 6 white rabbits and 3 not white rabbits. So out of 6 white rabbits, I'm gonna pick 1 white rabbit. As you can see, 0, 1, 2 is representing number of white rabbits, and not white rabbits are 3. Definitely, I'm gonna pick 1 because 1 plus 1 has to be 2. Let's check what is our answer. From the calculator, when I found, I also got 1/2. Now, Mr. Omar, we are getting the same answer. So why you said that we cannot use combinations? My friends, when we are talking about probabilities, because probability, we have something, the numerator is divided by something. In that situation, if it is with replacement or without replacement situation occurs, that the numerator and denominator nature, that cancels the effect of each other. So combination can be used, but a student needs to be careful, as he is going to pick one rabbit one rabbit from the 2 rabbits. So there are 2 possible cases we have, which we saw in the tree diagram case. But combinations definitely can be used. As you can see, it has shown you the same answer as the answer which we got it in the tree diagram situation, where we wrote all the possible cases. However, in combinations, the 2 cases are merged into 1, and we got the answer 1/2. In the same way, guys, we can get the probabilities for the next cases. He said, like, construct the probability distribution table for the number of white rabbits in the sample. So I can get this probability, and I can also get this probability. Again, I'm trying to convince you why, guys, combination works here, even though the question was without replacement, because up and down, both probabilities, both combinations we are taking, like when we write centimeter divided by centimeter, yani a length here and length here, centimeter, centimeter, they cancel the effect of each other. So the nature won't be disturbed of the question. So the probability, when we are trying to find it, even though the objects are similar, but when we do the probabilities, those effects, replacement without replacement, will not affect the final answer. That's why my answer was matching. Okay. However, to convince yourself, I did it the tree diagram, which will be helpful for you and tell you that yes, I did a right job, in which you clearly see the 2 cases I wrote it. However, these 2 cases were merged into this case, where I wrote 1 and I got the answer 1/2 correct. So 9C2, and I'm gonna pick from the 6, no white, but from the 3 not whites, I'm gonna pick all those 2. Right? And this gives you the answer 1/12. And when the random variable x is equals to 2, I will write 6C2 times 3C0 over 9C2. And this probability will give me 5/12. May I write it as 6? If I multiply up and down with 6, it gives me 6/12. So boys, add the 3 probabilities and you will confirm that, Mr. Omar, the sum of the 3 probabilities is equals to 1, which shows this is a discrete random variable probability. Okay, so no ambiguity must occur in your mind that, Mr. Omar, this is a chosen question and I cannot use the combinations. Combinations can be used, but in the case of probabilities, not only in combination situation. In combinations, if you want to choose only combinations, that you need to deal with the classical approach, okay, case to case. But if it is related to probability, yes, either go with the combinations or draw the tree diagram since the number of trials are not so many. If I was about to get like 5 rabbits or 6 rabbits, then tree diagram is not suitable for you. Then definitely you have to come up with combinations. But that question should be related to probability. Got it? Now we go to the question number 3, boys. Question number 3 shows, question number 3, find the number of possible arrangements of the 9 letters of the word celestial. Okay, so this is the word. We are interested into this word in terms of its letters. How many total letters it has? Total 9 letters. So total 9 letters. Just see how many same letters we have. 2 E's. We get it? We have 2 E's. We have 2 L's. And 4 others. 4 others or 5 others? 5 others. Yani C, S, D, I, and A. Correct? Find the possible number of arrangements. Very simple question. 1 mark it has. Total number of letters are 9. We can arrange them in 9 factorial ways if they were all different. But unfortunately, the letter E is repeated twice. So we have to divide 9 factorial by 2 factorial because of 2 E's. And again, I have to divide by 2 factorial because L is also repeated twice. So this 2 factorial came for 2 E's. And this 2 factorial came because of the 2 L's. But total letters are 9 factorial. My final answer comes to me 90720. Clear? The B part. Find the number of different arrangement of 9 letters in the word celestial in which the letter C is the first. So fix the position of C. And the 5th position will be carried by T. And last position will be taken by letter E. So first position is fixed. 5th position is fixed. And the last position, 9th position, is fixed. We are not gonna change these positions. So shuffling will be done only for 3 letters in between C and T and 3 letters between T and E. So shuffling will happen only here. Can you count how many these letters are? 1, 2, 3, 4, 5, and 6. In how many ways these 6 letters can be arranged? Mr. Omar, clearly 6 factorial. But please make sure, is there any letters among these 6 letters repeated? Yes, L is repeated twice. Since E has been already used, it means E is alone in these 6 letters. So the possibility of getting 2 L's among these 6. So that's why I will divide with 2 factorial, and this 2 factorial I wrote it because of 2 L's. Clear? And now let's check the answer. What is the answer we are going to get? It would be 360. So 360 ways in which the position of C at the first, T at the fifth, and E at the ninth place fixed. Don't change them. Only the variability will be seen in 1, 2, 3, 4, 5, 6 positions, which are shaded by me as pink. And there are 6. We can do them in 6 factorials, but among these 6 factorials, 2 L's are there. So I have to divide with 2 factorial. I hope it is clear to you. Now we go to the C part, boys. In the C part, find the probability that a randomly chosen arrangement of 9 letters in the word celestial does not have the 2 E's together. So does not have the 2 E's together, guys. We have 2 normally methods which we can use here. So let's try to use the first method in which I will try to put all the letters which are not E's, because we want to put the E's separated from each other. Okay, so other than 2 E's, I have 7 letters. So I'm going to make 7 boxes. 1, 2, 3, 4, 5, 6, and 7. So my friends, in these 7 places, you're not gonna use E's. In these 7 places, I'm asking you to use other letters, which includes L's as well, okay? So there are 7 letters. In how many ways we can arrange them? In 7 factorial. Do we have any repeated letter? Yes, Mr. Romer, 2 L's are still there in these 7. So divided by 2 factorial, done. Is my job over? No. Now you have spaces around. Now you have spaces around these 7 green spaces where we have already put the letters. And this pink area is showing separation of E's. So the possible places for E is 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 possible spaces for E's to come. And I'm gonna use only 2 spaces from them because I have 2 E's. So I write 8C2. Is it clear? 8C2. Once I select them, then I have to place them. Yani I will say that those two E's, I can shuffle them in 2 factorial, but since they are the same, I have to divide with the 2 factorial. They will be cancelled. So no need to write this 2 factorial by 2 factorial. But this 8C2 tells you that, let me use the pink color. This 8C2 tells that I have total 8 spaces, and out of the 8 spaces, I am gonna use only 2 spaces to put those 2 E's. And E's are same. That's why I did not write times 2 factorial, because that was 2 factorial divided by 2 factorial cancelled. No need to write that. So 8C2. However, 7 factorial over 2 factorial came because I have already placed the 7 other letters from E's in which 2 L's were there. It can be done in 7 factorial divided by 2 factorial. I hope this method will work with you guys and the answer will come to us. Is it a probability question or a simple question? No, Mr. Romer, it is a probability question. So in the probability, guys, I have to divide with the total situation. Did I already find 90720, guys, which is without restriction? If you want to write it 9 factorial divided by 2 factorial times 2 factorial, that's also right. Or if you want to write here 90720, that's also fine. Again, I will try to convince you. In the denominator, why Mr. Omar has written without restriction, and I have 9 letters, and in how many ways I can arrange them in 9 factorial ways. Why I divided by 2 factorial, because there are 2 e's and 2l's. Done. So this is without restriction. Whenever we write probability, boys, whenever I write probability, the denominator is always without restriction. Possible ways I have to write it. And the wanted situation, yani restriction, is always in the numerator. And this restriction shows that I am not gonna have yani e's together. So e's are separated. This is the restriction I have. E's are separated. E's are separated. Is there any question, guys? I hope like everything is well understood by you. So let's go with the next question. I think this method will work with you. Although we can go with the second technique, and in the second technique, guys, I can look into these 9 letters, and the 9 letters, I want to make them separate. So I will use the complement way. You remember the complement way? The 2 e's are together, and then I will subtract it from 1. I will get the probabilities of 2 e's together. If you really want it, I may explain it to you here with with a simple clue that find the probability. This is method number 2. If you want to use method number 2, method number 2 is find the probability that 2 e's are together. If 2 e's are together, you remember that we have to put like this, yani e's and e's together, and it will be considered as 1. Now others are how much? Yani I have 7. Because total we have 9. So 2 are gone here. So 2, 3, 4, 5, 6, 7, and 8. Now, in how many ways we can do that, guys? How many ways we can shuffle them? In 8 factorial, okay? In 8 factorial divided by 2 factorial, because you remember that we can do this thing in 2 factorial ways, okay? Because there are 2 L's are still over there, correct? And then divided by the probability without restriction, it is 9 factorial over 2 factorial times 2 factorial. Once you find it, guys, and then 1 minus when you write, you will get the corresponding probability. But I am not using the second method here. This is only for those students who are willing to use the complement situation. So the final answer comes to me 7 over 9 for this case. Let's go with question number 4, boys. Now, question number 4 is, Isam has 11 CDs. Isam has 11 different CDs, of which 6 pop music and 3 are jazz. Okay, 3 are jazz. And 2 classical. So total 11 CDs, 6 pop, 3 jazz, and 2 classical. Done? Now, how many different arrangements of 11 CDs on a shelf if the jazz CDs are all next to each other? If I want to put jazz CDs next to each other, I will make a block. Jazz, jazz, and jazz. And all CDs are different. So these jazz CDs doesn't look like the same. So these are different jazz CDs. Internally speaking, in how many ways we can shuffle them? Internally, guys, 3 factorial ways I can shuffle them. Now, externally, it will be considered as one CD for me, any one thing for me. Wherever I place this, jazz CDs will be kept together. How many others? The others are 8. And he did not put any restriction on pop CDs and classical CDs. Now, total CDs. 9. Clear? In how many ways I can shuffle them, guys? Externally, I can shuffle them in 9 factorial ways, and all of them are different. Times internally, the jazz CDs can be done in 3 factorials. I write here 3 factorial. And externally, this is considered as 1, 2, 3, 4, 5, 6, 7, 8, 9. It can be done in 9 factorial ways. So my final answer comes here as 2, 1, 7, 7, 2, 8, 0. But I can also write it into 3 significant figures. So 2, 1, 8, 4 zeros. That will give us the final answer. Right? Let's go with the second part. Isam makes a selection of 2 pop CDs and 2 jazz CDs and 1 classical CD. My friend, 6 pop, 3 jazz, and 2 classical CDs he has. He wants to pick 2 pop, 2 jazz, and 1 classical CDs. In how many different ways we can do that? Very easy. 6C2 times 3C2 times 2C1. Is it a probability question? No, we just want to do the selections. You understand? If it was a probability, I should have written what? I want to pick 5 CDs and total 11. I was writing 11C5, but it is not a probability question, so no need to divide with anything. Clear? Now we are going to multiply them together and get our final answer, which gives us 90. And that's all. Let's go with the question number 5. In question number 5, he says, a school club has members from 3 different groups. Year 1, Year 2, and Year 3. There are 7 total. Let's check how many 3-year groups. There are 7 members from Year 1. There are 7 members from Year 1. 2 members from Year 2 and 2 members from Year 3. Year 1, Year 2, Year 3. Clear? So we have 7 for Year 1, 2 for Year 2, and 2 members from Year 3. 5 members of the club are selected. So total 5 people are going to be selected. Find the number of possible selections that include at least 1 member from each. Wow. Guys, is it possible that if I pick here 2, 2, 1, can I write it? 2, 2, 1. Can I write here 2, 1, 2, is it possible? Can I write here 3, 1, 1? Can I write here 1, 3, 1? No, Mr. Omar, we have total 2, so 1, 3, 1 is not possible. Can I write here 1, 1, 3? No, we don't have 3 people in year 3, so don't write it. Do we have any other possibilities, guys? Yes, I can write here 1, 1, 2, 2. This is possible. So 1, 2, 2. These are the only 4 cases we have. Now we have to write these 4 cases. So first is 7C2 times 2C2 times 2C1. For this one, total 7. I'm going to pick 2 from year 1. Total 2. I'm going to pick 1 from year 1. Total 2. I'm going to pick 2 from the year 3. 7C3 times 2C1 times 2C1. And the last one is 7C1 times 2C2 times 2C2. So the first one comes to me, this one 42, guys. And this is also 42. And this will come to you as 140. And this will come to you as 7. Now we need to add all of them. And the final answer comes to you 231. Let's go to the question number 6 now. In question number 6, in a large college, 28% of the students do not play any musical instrument. 28%. 52% play exactly one of the musical instrument. And the remainder play 2 or more musical instrument. Clear? Can I just try to find it? 100 minus 28 minus 52. So 20%. So 20% play 2 or more musical instrument. A random sample of 12 students from a college is chosen. Find the probability that more than 9 of these students play at least one musical instrument. So at least one musical instrument tells you maybe one or more. Maybe one or more. So 52 and 20. We need to add them up. So 52% plus 20%. It is equals to 72%. So our success is for every student is 72%. It is a binomial probability distribution. Our random variable is representing at least one musical instrument, and it follows the binomial distribution. And we remember binomial distribution depends upon the number of trials, which is 12, finite, and the probability of success is 0.72. This is N and this is P, and the Q, the probability of failure is 0.28. Now he says more than 9, X more than 9. So more than 9, can I write all the cases? X is equals to 10. X is equals to 11. And X is equals to 12. If I write the case for 12, C total is 12 trials, 10, Q 0.28, 12 minus 10, it is 2. Successes 0.72, we have 10 successes raised by 10. Now 11, total 12. Out of 12, I'm gonna pick 11. 0.28 raised to the power 12 minus 11 is 1, and 0.72 raised by 11 plus 12C12, 0.28 raised by 0, and 0.72 raised by 12. And it gives us 0.304, the final answer. No need to take the complement because we don't have, a large number of cases to be added. Just 3 cases. It was very easy to add them up. Let's go to the last question. Biscuits are sold in packets of 18. Biscuits are sold in packets of 18. There is a constant probability that any biscuit is broken. So look, he's trying to model the binomial distribution in this situation. That's why he said the probability is constant in every trial. The biscuit is broken, it might be the success for us in this case. And another thing he said, like every broken biscuit independent from the other biscuits. The mean number of broken biscuits in a packet has been found to be the mean number. So biscuits are sold in a packets of 18. Every packet has 18 biscuits. And the mean number of broken biscuits is 2.7. He did not give you the probability of success. He gave you any X represents what? X is the random variable, boys, and it is giving you the number of broken biscuits. Clear? So probability, this is binomial distribution, N is 18, and the probability of success is not provided to you. Now X represents what? Number of broken biscuits. And mean is given by him. Mean, which is represented by mu, and the formula in the formula sheet, you can also see it is equals to NP. Mu is 2.7, and the probability of success is required. Number of trials are 18. I can easily find the probability of success, 0.15. Now, in this question, he said, I have to find the probability that the packet contains 2 biscuits, 3 biscuits, or 4 biscuits, because he wrote inclusive. When a word between is written, it means between, not 2, not 4, only 3. But when he uses a word inclusive, I have to take the endpoints as well. So he's asking you, what is the probability of X from 2 to 4? So there are 3 cases. You have to find the probability of X is equal to 2. You have to write the probability of X is equal to 3, and probability of X is equals to 4. So X is equal to 2 will be total number of trials are 18, and I'm gonna pick 2. Success is 0.15. Now first write failure. Failure is 0.85 raised to the power 16, 0.15 raised by 2. For X is equal to 3, 18C3, failure 0.85, 18 minus 3 is 15, 0.15 raised to the power 3, plus 18C4, 0.85 raised to the power 14, and 0.15 raised by 4. When we add all the 3 cases, guys, I will be getting 0.655. And that's all with this exam style questions. I put 7 questions and it gave you a thorough revision for the final exams. As you can see, the first 2 questions which I put it over there, it gave you good practice on discrete probability distribution. Question number 3, question number 4, boys, and question number 5 gave you good practice on combinations and permutations. Question number 6 and question number 7 are related to binomial probability distribution. Soon I will be making the video for the revision pack. That will be also very helpful for you because it contains more questions, and I will discuss furthermore about all the concepts in that video. Hopefully, we are done successfully this work for this explanation of 7 questions which were related to all the chapters which are actually given in the study list. So thank you guys. Inshallah, see you next time. Assalamu alaikum wa rahmatullahi wa barakatuh.